Have you ever wondered what makes pancakes so fluffy and airy while crepes are flat?
I'm sorry to break it to you, but this isn't magic.
But actually, the answer is leavening agents.
Leavening itself means to lighten or cause to rise. But what are the leavening agents? Well, they can be separated into chemical and biological ones. Chemical leavening agents include examples such as baking soda.
And baking powder, while biological leavening agents include yeast.
Let's begin by talking about yeast.
Well, yeast is actually a living organism. It's a single celled fungus.
But how does a fungus help the bread rise? Just like all living organisms, yeast respires, which means it feeds on sugars and starches and breaks them down to be used as energy.
Just like with all living organisms, waste products are produced. In the case of yeast, it's carbon dioxide and ethanol. The carbon dioxide produced is a gas, and therefore it gets trapped in the dough and consequently makes the bread rise. This can be shown by the following equation. Here we can see that sucrose is broken down to ethanol and carbon dioxide.
Before grocery stores and fancy cake recipes, if you wanted to make your bread rise, you needed leavening agents from natural sources. And so bakers would leave their dough sitting out so that wild yeast from the air would move in. Around the 1830s, bakers started figuring out that they could create a quick chemical reaction themselves so they didn't have to wait for the yeast to do its thing. That way, other baked goods like cakes and biscuits could be lighter and fluffier. So the use of chemical leavening agents began. One of those leavening agents is baking soda, which, if you were to give its chemical name to, it's sodium bicarbonate. It's a compound with a high pH, meaning that it is basic. It is made from soda ash, which at the time came from the ashes of sodium-rich marine plants like seaweeds, or it was made by synthetically reacting table salt, also known as sodium chloride, with other chemicals and minerals.
Today, the compounds needed to produce soda ash and baking soda also come from mines.
The baking soda you find on the supermarket shelves now is the same compound that we've been using for almost 2 centuries.
Usually, sodium bicarbonate reacts with acidic ingredients in recipes, such as buttermilk, brown sugar, lemon juice, and chocolate.
For example, if sour milk is used, which is full of lactic acid, it would react with sodium bicarbonate and produce bubbles of carbon dioxide. So these bubbles of carbon dioxide could puff up the bread dough or cake batter.
And although this reaction worked well for bakers in making the bread rise, the acidity of the sour milk still wasn't consistent, and neither was the final product.
In the 1840s, cream of tartar, also known as potassium hydrogen tartar or potassium bitartrate, started being used.
It is an acidic byproduct of wine fermentation, and so when you mix it with sodium bicarbonate and some water, carbon dioxide bubbles are produced.
Cream of tartar helped make the chemical reactions in baking more consistent, but there was one big downside. The availability and price varied, depending on the grape harvest in a given year. Then Eden Horsford, in 1856, figured out how to make an acid called monocalcium phosphate from beef bones. If you mix monocalcium phosphate, baking soda, and water, carbon dioxide bubbles would be produced. So Eden Horsford created the baking powder by mixing monocalcium phosphate, sodium bicarbonate, and adding some cornstarch that helped keep everything dry because it absorbed the moisture and thus prevented any early reactions. This helped elongate the shelf life of the baking powder.
This explains why sometimes in recipes the wet and the dry ingredients are mixed separately. It prevents the reaction from happening too early and all the gases from escaping.
And then in the 1880s, people realized that they could extract monocalcium phosphate from mines, so beef bones were no longer required.
Nowadays, most of the baking powder you find in stores is labeled as double-acting.
Unlike the single-acting one that contains only one acid, usually tartaric or phosphate acid, and one base, and so reacts only once when added to liquid, double-acting powders have a second acid that is heat-activated, usually sodium aluminium sulfate, and so they react and create carbon dioxide during the mixing process just like single-acting powders, but the second acid is activated during the cooking process, allowing further gas release. Some of these heat-activated acids can contain aluminium. Some people avoid double-acting baking powder because they're worried about the health effects of aluminium. However, the CDC says that the amount people consume in foods isn't enough to be dangerous. Either way, other double-acting baking powders are aluminium-free and use compounds like sodium acid pyrophosphate instead. So there you have it. Baking soda is just another name for sodium bicarbonate, while baking powder is sodium bicarbonate plus an acid or two and some cornstarch. Basically, an all-in-one chemical mixture just waiting for moisture and heat to get the reaction going.
Now let's see what leavening agent will make the dough rise the most. Firstly, I'm going to weigh out all of the ingredients that are needed to make the dough, starting with salt, then baking flour, and lastly water. Now that we have weighed out all of the ingredients, we can mix them in one bowl. Now we will create a proper dough by mixing all of the ingredients with the mixer. Now we need to divide the dough into 4 equal parts. I made sure that this was done accurately through the use of a scale. This way I could be sure that all of the 4 parts were the same mass. These are the leavening agents we are going to test in this experiment. We are using baking powder, yeast, and baking soda. First, we need to weigh out 5 grams of each leavening agent. First, 5 grams of the baking powder, now 5 grams of yeast, and lastly 5 grams of baking soda. Now we are adding different leavening agents into different cups that contain the same amount of dough, while leaving one of them with no leavening agent as a control. Once the leavening agents were added into each cup, I mixed the dough in each cup to make sure that the leavening agents were evenly spread out. Then I labeled each cup to be able to distinguish which one is which. I let the dough stand for 20 minutes. These are the results. After 20 minutes, we can see that the dough containing yeast has risen the most. The dough containing baking powder and baking soda has risen a bit, but less than with the yeast. While the control one hasn't risen at all since it has no leavening agent. Then I prepared the dough for baking by placing them on a tray and labeling them. Now we are putting the dough in the oven, and here we can clearly see that the dough containing baking powder has risen a lot less than the dough containing baking soda. Now this is what it looked like after 10 minutes in a preheated oven at 180 degrees. This is what it looked like after 15 minutes. After 20 minutes, the baking process has finished. I've cut each of them in half so you can clearly see the differences. The height of the control bread is around 2.2 to 2.3 centimeters. The height of the bread that was baked with yeast is around 7.2 centimeters. The height of the bread that was baked with soda is around 3.8 centimeters. The height of the bread that was baked with baking powder is around 3.5 centimeters. So overall, we can see that the bread baked with yeast has risen the most, the control one hasn't risen at all. The bread baked with baking soda has risen a bit more than the bread baked with baking powder. The small increase in the height of bread baked with a baking soda and baking powder is probably due to the fact that we left the dough for 20 minutes, so some of the carbon dioxide could have escaped. However, we can still see that leavening agents are what in fact makes the bread rise, since the control that doesn't have any leavening agent does not rise at all. Now you know how leavening agents work. Next time you're enjoying your fluffy and airy pancakes, make sure to thank chemistry for that.